Moving swiftly on today with human populations, we'll talk about how populations are modelled and a specific type of model called the demographic transition model, which generally we'll refer to as the DTM because it's such a mouthful. By the way, I've not mentioned this before. Demographic comes from the Greek word demos, meaning people or population. Graphic means writing or describing. So demographic is a description of human populations. And transition obviously is change either in time or from place to place. So we're talking about a model that describes how populations change. And we talk about how it changes in basically three ways, as you can see above my head. We'll refer to change in terms of the crude birth rate, the crude death rate, and the natural increase rate. And then later on, we'll combine everything with population pyramids. So basically, this model is combining all the things we've looked at in the previous three videos. Population statistics, population change, and population pyramids. I think if you've still got any doubts about any of that stuff, it'll be a good idea to go back over that before we go any further with this. But I've got a feeling you should be all right with all that stuff already. Okay, let's take a quick look at the syllabus and what it says. It's actually very straightforward. A bit surprising, really, because the DTM is something that just seems to come up every year or year on year in either paper 1 or paper 2. It's something that the IB really like to test you on. But it's quite a brief description in the syllabus. I've just noticed actually that the IB, they refer to age-gender pyramids, and I've called them population pyramids in the past. I'll probably just continue to call them population pyramids, but just be aware that it's the same thing. So the syllabus says population pyramids and the DTM are useful in the prediction of human population growth. That's self-explanatory. And then it says the DTM is a model that shows how population transitions from a pre-industrial stage with a high crude birth rate and high crude death rate to an economically advanced stage with low or declining crude birth rate and low crude death rate. Pretty much what I've said before. So the DTM shows you how you go from a pre-industrialized society to an industrialized society. We've already seen that to some extent when we looked at different population pyramids, so you'll see that links into what we're going to talk about today. And then for applications, it basically just says that you need to be able to analyse population pyramids and diagrams in terms of the DTM. So it's very brief, and it shouldn't take me long to get through it. Okay, so just before we move on, just a little reminder of what we talked about before. I already said that the DTM combines three statistics: the crude birth rate, the crude death rate, and the natural increase rate. So just a reminder of what that means. The crude birth rate is the number of births per 1,000 people per year normally. Let's say we have, in a certain country, certain made-up country, we have 65 births per 1,000 people in a year. And let's say in that same country, the crude death rate is, let's make it fairly simple, 45 deaths per 1,000 people per year. Okay. The natural increase is going to be 65 minus 45, which hopefully my math is correct, which is 20. In order to convert that into a natural increase rate, in terms of percentage, we need to divide that number by 10, which gives us a natural increase rate of 2%. Sometimes that's called a growth rate. So a growth rate or natural increase rate of 2%. That's actually quite high. The global natural increase rate at the moment, Google is our friend, and I Googled it just before I started this. The current natural increase rate globally is 1.1%. I Googled again. In the 1960s, the early to mid 1960s, just after the baby boom, the global natural increase rate was about 2.5%. So that was around 1964, 65, I think, 2.5%. So the natural increase rate is falling. If you look at some countries, the highest natural increase in the world is Niger. We looked at this before. Niger currently has a natural increase rate of, I'll just check, 3.8%. What that means in Niger is that it has a high death rate, but a really, really high birth rate. So the birth rate is outstripping the death rate, and the population has a very high increase rate, natural increase rate. That's followed by Uganda. Uganda has a natural increase rate of, let me check, of 3.3%. So countries where they have maybe a declining death rate but still a very high birth rate have a natural increase rate. And we'll see that when we look at the model. Okay, this next slide is the model. Now I know this looks complicated, but for the time being, please just ignore all of the text at the bottom down here and we'll just concentrate on the graph. The graph is actually very simple. And then when I finish speaking, just pause the video please and have a look at the other text underneath. I'm hoping that you can read it. All right, so you can see this graph has 3 lines. A grey line and a black line and then this red line. The green shading shows you the difference between the grey line and the black line. So the grey line represents birth rate, the black line represents death rate, and the red line, it's the difference between them divided by 10, which is the natural increase rate. So it's very straightforward. We say that if a country is in stage 1, here, this is stage 1 between these 2 lines. Stage 1 of the DTM is a country with a very high birth rate and a very high death rate. The difference between them is very small, so therefore the natural increase rate is, that says total population here, but I'll refer to it as natural increase rate. The natural increase rate is low. Okay. For most of human history, most human societies were like that. Today, very few are, because very few societies these days don't have a falling death rate due to the introduction of modern medicine. A few exceptions would be very remote tribes, maybe in the Amazon, somewhere like that, where there's no access to outside medicine and outside education. That's stage 1. When we move to stage 2, the birth rate is still very high, but the death rate is decreasing. And there's quite a big difference as you move through stage 2 between the birth rate and the death rate. Because of that difference, the natural increase rate is going up, and therefore the population is expanding, population is growing. So stage 2, well, I mentioned before Nigeria, Uganda, some of those other African countries that we talked about before. Basically countries where they have increasing access to healthcare, sanitation, medicine, but the birth rate is not decreasing for social reasons, tradition, religion, lack of sex education, perhaps lack of family planning or contraception, all of those things. Okay, so that's stage 1, stage 2. Then we get to stage 3. Stage 3 is a population where the birth rate is decreasing and the death rate continues to decrease but less rapidly. There's still a fairly big difference between the birth rate and the death rate, and therefore natural increase rate continues to rise. So it's still a rising population, but it's beginning to show signs of plateauing off. So the natural increase rate is falling. The example I mentioned before in a previous video would be perhaps India. India, we would say, is in stage 3 of the DTM. Example here is Brazil. And then we get to stage 4. Stage 4 is a highly industrialized countries where possibly the majority of the population live in urban areas, good access to healthcare, sex education, family planning. And we can see here the birth rate has fallen, very low, and it's pretty much balancing out the death rate. And because of that, because the birth rate is balancing out the death rate, you can see that the natural increase rate has plateaued. The population is stable. Okay, so if we go back to what the syllabus said that the DTM, the demographic transition model, shows you it's a model of movement from a pre-industrialized society to an industrialized society, and you can see those 4 steps getting there. That's about it, really, except we'll see here that there's a stage 5 with a question mark after it. The reason is stage 5 appears to exist, but it's quite a modern phenomenon. It seems as if some countries may just be transitioning into stage 5 of the DTM, and we don't have a lot of data to support that, although it seems to exist. The example that I mentioned before would be Japan. Another example here, Germany. Those are countries where the birth rate has flattened out, but you get to stage 5, the birth rate doesn't just flatten, it continues to decrease until the birth rate has fallen below the death rate, which means you have a declining population and a natural increase rate that is now falling. Now, I did mention this before. Japan is at a stage now where the fertility rate is very low. The total fertility rate is low because women are choosing careers over having children. And therefore, Japan has reached this problem where it has a small young population supporting a very large older population, which is not good. Most countries strive to move towards stage 4. Stage 4 is where you've got a stable population, a low birth rate, and probably, although you can't see it on this model, a total fertility rate close to 2.1, which is the replacement rate. It's bad news when a country seems to transition into stage 5. Okay, so I'd suggest before you move on, it's a good idea to just pause and have a look at the text down here. It pretty much just covers what I've said already. You might notice that there's a y-axis, which is basically births and deaths per 1,000 people. Really, there should be a second y-axis here, which refers to the red line, which I've taken as natural increase rate, usually, although it does say total population there. And there's no x-axis on this graph. That's because the x-axis could represent transition over time, maybe from 300 years ago to the present day, or it could represent transition from country to country, from stage to stage. So that's a little bit vague. Okay, so I hope that made sense. The final slide. You can also represent the DTM in terms of population pyramids. Very often you'll see a DTM model with the pyramid superimposed on the graphs we saw before. But basically it shows the same thing. So in stage 1, very high base, very large base of the pyramid, so therefore high birth rate, and very, very steeply sloping sides, which represent a very high death rate, and a birth rate that balances the death rate. Stage 2, Nigeria, Uganda, those countries, large base, possibly decreasing slightly on this one, but a very high birth rate, but not as steeply sloping sides, which represent an improvement in a decrease in the death rate, we could say, due to the introduction of healthcare, sanitation, and medicine. Stage 3, I suggested this was India. It shows a decreasing birth rate and an improved a decreasing death rate as well. Sorry. So therefore, these older generations possibly represent people that were, the older generation that were affected by the previous stage of the model. Stage 4, industrialized countries, US, UK. This represents a pyramid that's that's a strange shape one, that one. A pyramid that kind of slopes upwards, and you have populations that are equally likely to die at middle age, and then a big die-off at the top when people reach old age. And then finally, stage 5, I mentioned Japan. It's a very top-heavy pyramid where a small number of young people are supporting a high number of old people, and that's representative of a declining birth rate and a low death rate as well. Okay, that's about it. I hope that made sense. I'm going to post this with some work that will hopefully help you to make more sense of both the diagrams in terms of the graph and in terms of the population pyramids. Okay, take care everybody, and I will see you in the next lesson.